Wonderful. I saw it pop up. Thank you. All right, well, we'll go ahead and get started here. I don't know if Ben and John will be able to join. Matt's in the room with me here. But looking forward to talking to you guys today about this. Obviously, audio has a lot to do with what we do, and I'm excited to talk to you about this because it's kind of a passion of mine. I've always kind of been an audiophile, been into music, went to school for audio recording, and so this is kind of near and dear to my heart. But for today, we're going to kind of get back to basics here. Let me just pull up my notes. All right. Get set here. All right, so let's start off with some basics. What is sound? Sound is vibration that travels as mechanical waves perceived by the human ear. It is characteristic. It's characterized by properties such as frequency, amplitude, wavelength, and these things determine pitch and loudness. This is where the term sound pressure level, or SPL, originates. SPL is measured in decibels, or dB. Decibels are logarithmic with a base of 3. Therefore, every 3 decibels, the sound either doubles or decreases by half. While reading on a meter from 75 to 78 decibels, that might not seem like a very impactful change. In reality, what's happening with the physics is extremely impactful. Let's go to the next slide here. Sound waves. Sound waves are longitudinal waves that consist of compressions and rarefactions. They vary in frequency and amplitude, which dictate how we perceive sound as pitch, volume, and pitch and volume. Let's dive into these a little bit. So, frequency and pitch. Frequency refers to the number of vibrations per second, which is measured in hertz. It determines the pitch of a sound. Higher frequencies produce higher pitches, lower frequencies produce lower pitches. This affects musical notes and sound perception in events. Every time the number of hertz doubles, the pitch changes by 1 octave or 8 notes. So for instance, 440 hertz is an A, and is the basis for tuning violins and other stringed instruments. However, 880 hertz, obviously double 440, is also an A. It's just an octave higher. Having a handle on this concept and digging into ear training becomes applied when using EQ to sweeten a sound or identify the frequency of feedback. Next, let's talk a little bit about amplitude and volume. Amplitude measures the strength of a sound wave, determining its perceived volume. Greater amplitude results in louder sounds, while lower amplitude produces softer sounds. Effective volume management is key to maintaining a pleasant auditory experience during events. Audio too soft can cause listeners to strain to hear or comprehend the speaker, while audio too loud can cause ear discomfort and ultimately fatigue through the course of the event. Next is speed of sound. This is very important in events because of the proximity and the space of many of the locations where events are produced. The speed of sound varies depending on the medium, air, water, solids. We're primarily talking about air in this conversation. In the air at 68 degrees, it travels at approximately 347 meters per second. Understanding this characteristic helps in synchronizing audio and video elements in events, ensuring coherence of those two elements. Since the electrical signal flowing through a system or cable travels faster than it does in the air, sound perceived further from the source will be put on a delay. This is normally done through a DSP or other programming method. This ensures that the audio from the speakers is synchronized with any ambient sound coming from the source. So if you have a band on stage, the ambient sound from that band is going to travel slower through the air than the electrical signal will through the cables that ultimately come out the speakers. Therefore, the speakers have to be put on a delay in order for those two things to be synchronized. Speaking of electrical signals, how does sound turn into an electrical signal? In order to convert sound waves into an electrical signal, in order to be mixed, processed, routed, etc., a transducer must be utilized. A transducer, better known as a microphone, is nothing but a tool to convert sound waves to an audio signal. In its most basic form, as you can see here, a dynamic microphone consists of a diaphragm that actuates a small coil to move back and forth over a field, producing electrical pulses. The pulses become an electrical current that is ultimately sent down the connected cable. Should the microphone be wireless, the system will also include a transmitter, which will convert and prepare the electrical signal to be communicated to the paired receiver over radio frequencies. So, you might be asking, why does this matter? So let's get to a little bit of application. Microphone technique. Understanding how the transducer captures a sound wave is vital to understanding how a lavalier microphone should be placed on a presenter, or how a member of a panel should position a handheld microphone when speaking. And I have some examples here. We'll talk a little bit about it. Lapel microphone placement, for instance, there's three main things when it comes to lapel microphone placement. Ensure that the microphone is approximately 8 inches from the speaker's chin. This will ensure that no plosives, P's, B's, etc. Produce sort of a bang or a pop on the far end or in the space coming out of the audio system. Number 2 is to keep the microphone free and distant from any jewelry, as it may introduce unwanted noise. As an example, when I put this microphone on, I had my glasses right here. So obviously that's not a good idea, just like necklaces or any other types of jewelry that people may have, because you'll hear that clanking and whatnot throughout the presentation, and that's not enjoyable for anybody. Number 3 is to ensure the microphone is placed as close to the center of the presenter's body as possible. This is to avoid dynamic changes as they turn their heads. So if I turn my head one way or I turn my head the other, if it's in the center of my body, the dynamic range of my voice stays primarily standard. However, if it's on one side or the other, when I turn my head the other way, my voice is going to go away and come back and go away and come back. This is especially obvious when you're in a situation where there's a panel and the person leading the panel is on one side and they're continually turning their head to the panel and then turning it back to the audience and panel audience. And with those changes, you'll see the fluctuation in volume of the microphone. So it's important to keep that in the center of the body as much as possible. Oh, and by the way, real quick, one thing I was just thinking about after I wrote my notes was that with this knowledge gives us the power ahead of time to also prepare the meeting organizers for what the presenter should wear if they have any control over that. A lapel or a button-up shirt or something to that effect is very beneficial when it comes to miking somebody up on that's going to be on stage. Things like blouses with ruffles around their neck and things like that, big necklaces and all of that tends to create problems when it comes to lapels. So best to sort of consult ahead of time and prepare if at all possible. Next, handheld microphone technique. You want to hold, I think I made some bad grammar there, sorry about that, handhold or horizontally. You want to hold the microphone horizontally. You don't want to hold it like an ice cream cone, because then, as we discussed with the microphone, you have the diaphragm, your voice is going over the diaphragm and instead of into the diaphragm, which is not going to actuate the diaphragm properly in order to turn that into the electrical signal. So you're going to get a more thin or flimsy sound if you're not holding it appropriately this way. The other thing is to hold the microphone approximately 1 to 2 fists away from your mouth. That, again, similar to the lapel placement, is going to create a situation where you don't get the plosives, P's, B's, etc., directly into the diaphragm. They're going to sort of spread out before they get to the diaphragm. Number two is to speak or sing. Obviously, that's not as applicable normally. When you have a microphone, a lot of people, over project or overwork their voices. That can be bad, for an hour presentation to strain your voice that way. When you have a microphone, that's the whole point of the microphone, to speak normally, and we can help consult presenters in this fashion. Number three is to mix by proximity. This is mainly more in the music world, but can also apply to our situation with talking heads as well, where if there's a particularly passionate part of the presentation that, they're cognizant of the distance that the microphone is from their mouth, and you can sort of, help ensure that the audience doesn't get blown out, on a particularly passionate part of the presentation by simply controlling that distance. All right. Next, I want to talk about the next area that this is applicable, all of these concepts with the characteristics of sound. Audio signal processing. The first step in the signal flow on any audio mixer is the preamp gain, preamp/gain. The preamp is a physical piece of the mixer where the audio comes in, and the gain allows you to amplify or attenuate the electrical signal that's coming into the audio mixer. Let's talk a little bit about what this is, but also what it's not. So preamp gain is utilized to ensure a healthy electrical signal that moves through the audio mixer. That's all it's for. It's not for volume control. It's not for mixing. This should never be used in that fashion. All it is to get the electrical signal to the desired level to ensure that you can mix properly via the faders and the master. Also included in here in this diagram is what's called a pad. This is if the electrical signal coming into the audio mixer is too high on its own. The audio mixer will have a button or a knob for a pad. And what this does is allows you to attenuate that incoming signal to ensure that it doesn't overdrive or clip at the fader. Next is the next stop on the signal flow chart is dynamics processing. This includes things like gates, compression, limiter, EQ. So let's kind of dive into each one of those. So a gate is utilized to mitigate extraneous noise normally. There are other applications when you stylize drums and things like that in a musical environment. But primarily, it's just to cut noise. And it does this by opening and closing to allow a signal to pass only if the signal surpasses an amplitude threshold that you set. It cuts it off if that sound drops below the amplitude threshold that you set. As you can see on what's displayed here, there are many elements of a gate. We're not going to dive into all of that, but there are many things that you can set to your desired sound and to make it sound natural, depending upon what mixer you have and what options it has. Apologies for that really granular picture. Next, compressor. A compressor actively suppresses the audio signal when it reaches a desired amplitude. So it's kind of like the opposite of a gate. Well, not the opposite, but it's sort of a lesser gate, let's say that. So the compressor has a ratio, and what that ratio is basically how hard it clamps down on an audio signal when it reaches the threshold that you've indicated. Anything higher than an 8:1 compression ratio is generally regarded as a limiter, and what a limiter does is essentially cuts it off altogether to ensure that there's no damage to speakers or other components when it reaches a certain amplitude. Next, an EQ or equalizer. An EQ offers variable frequency amplitude control. This allows us to craft the sound to improve the quality of the final experience. It also allows us to take care of feedback. In the course of feedback remediation, a few different types of EQs can be employed to help that scenario. The first is a parametric EQ, which many of our audio mixers, you've probably seen that on the channel strip. In the case of the new mixers, it's in the touch panel. What a parametric EQ is use one dial to allow you to determine a certain frequency, another dial to determine the width that you want to change the amplitude of that frequency. So it could be from 100 hertz to 300 hertz, or 150 hertz to 200 hertz as you sort of hone in. That's called the Q. And then obviously the actual volume or amplitude control is then ultimately how you change what you've determined you want to change. A graphic EQ has an individual amplitude control for predetermined frequency bands. I'm sure you guys have seen them either in digital form or in physical hardware form. All right. So that covers dynamics processing. The next stop on the signal flow path, apologies, it's going through all of them again. Sorry about that. There we go. The next stop is the fader and the pan. This is volume adjustment per channel. Pan is stereo positioning. A fader allows us to adjust the volume of an individual channel. However, the catch is that you can only adjust the volume within the amplitude of the electrical signal that you've set at the preamp. So if you turn a fader way up, really all it's doing is raising the noise floor, and you're going to get a more noisy signal. If you adjust the preamp to provide a stronger electrical signal, you'll be able to lower the fader and essentially reduce that noise floor. This process is called gain staging. A pan is generally more done in recording than in live, but it is important to understand what the control does. And that determines how much of the channel's signal goes to the left or the right channel of the mixer's master input. So if you have a stereo field in your headphones, and there's some drums, you might notice that the snare is over here, the kick's in the middle, the toms kind of go across the front. That's utilizing the pan. Last on the stop, the signal flow stop, and these are broad categories, guys. I'm not getting into the nitty-gritty, but we have the master, referred to as the master bus. So what is a bus? A bus is a component of an audio mixer whose job it is to combine signals. The master bus is the final summing of all assigned channels, offering combined volume control prior to the output. So let's check our progress. We've learned how the sound from a presenter's voice enters a microphone and is converted into an electrical current. We've walked through the basic signal flow of an audio mixer, and now we'll look at the final steps in the signal flow before the sound is turned back into airwaves for the reference and enjoyment of the attendees in the space. From the mixer master output, the next stop on the journey is the digital signal processor, the DSP. What this does is it handles additional processing such as AEC, automatic echo canceling. It also handles peak limiting to avoid blown speakers and damaged equipment, and routing capabilities to be sent to different zones or destinations within the facility. After the DSP, it heads to the amplifier. An amplifier does exactly as the name suggests. It amplifies the low voltage electrical current that has been through each stage of the signal flow. This readies the signal to then be sent to the speakers. And the last stop on the journey before it gets back to the attendees or the listeners is the speaker. What exactly is a speaker? Well, a speaker is actually just a transducer like a microphone. It just works the other direction. As you can see from the diagram, it contains the diaphragm, the voice coil, all of the things that a microphone contains. It's just kind of flowing the other direction. So the electrical current flows through the voice coil, which creates pulses that actuate the diaphragm. The motion then of the diaphragm moves particles in the air, creating what we perceive as sound. So that's how it comes back out. So we've covered the entire signal flow of the sound from the presenter all the way through the components and back to the attendees, audience, listeners. Lastly, what are best practices for how to do this for an event? Well, the first one is sound checks. These are absolutely vital. They allow technicians to adjust levels, test equipment, ensure clarity, and reduce the risk of audio issues at the event. Next, it's imperative to manage noise levels in order to create the experience for the attendees or listeners. Sound too low, as we've discussed, it can create listeners to strain to comprehend or hear. Sound too loud can be damaging to ears, can be painful, and can create audio fatigue throughout the event. Engaging the audience through sound can enhance their experience. We use strategic audio cues, background music, and live soundscapes to create an immersive atmosphere that encourages participation. So it's a really valuable tool if you really want to come back to the hospitality piece of what we do. Ensuring clear and engaging audio is actually an integral part of ensuring the engagement of the attendees. And lastly, something we don't normally like to have happen and do, but we need to be ready for, is troubleshooting. Common sound issues can arise unexpectedly, so being prepared to troubleshoot is essential. You need to have backup equipment ready as necessary, extra microphones if you're in an environment where it's not integrated like this, extra cabling, speakers, amps, things like that. And create a checklist to address potential problems promptly. So as we go through our checks prior to an event, it's important to actually be going through some sort of a protocol so that nothing gets missed. All right. So to conclude, I guess real quick, we have a walkthrough in this space, but are there any questions from the content that I shared today? I know it's probably a lot of review, but hopefully some of it was at least interesting for you and applicable.
Yeah, this is just when they say sound out the room when they do that feedback, what's actually happening?
Ringing out the room? Yeah, okay. So Matt asked about ringing out the room. So when you ring out a room, what you do is actually you create feedback by increasing the volume of the microphones and potentially positioning them near monitors or speakers. And then as the feedback becomes exposed, you actually go normally to a graphic EQ. You don't normally use a parametric for that. You go to a graphic EQ and then you adjust the volume of that particular frequency band that's creating the feedback. And once you do that, successfully to a certain level, because you're pushing the volume of the microphone so far to create the feedback, you're able to essentially bring them back down to a nominal level and have a normal volume presentation with no feedback. Any other questions? Very good.
I have one. When you, for example, you say AKC, but there's 8 people.
Okay.
What's the basic level when you put on a microphone? Do you have on a low level on the graphic, or how do you basically do 8 microphones at once without testing it so it doesn't have feedback all the time? You know what I'm saying? Is there a trick? You just
so normally that's done prior with nobody in the space. Okay. And the idea is that if you've rung out the room effectively, as long as there's no acoustical changes to the space or changes to the the speaker system, it should be permanent. The only thing that really can change that is the degrading of the microphone capsules. If they are reproducing sound differently or something like that, there may be some adjustment that can be made, but for the most part, ringing out a room is relatively permanent when it's an integrated space. All right. Well, thanks a lot, everybody. Again, I really appreciate it. Was really looking forward to sharing this with you. Hopefully, it shows in my preparation. Really enjoyed it. So, appreciate it, and I will talk to you all later. Hopefully, I get to see you all soon.
Nice review.
Now, that's not a PowerPoint, it's a Prezi? What is that?
Yeah, it's powerful. It's just a different vendor.
Oh, okay.
It's not a Microsoft product.
No.
Yeah, check this out, Matt. The way that Prezi does it.
So it's like Android, iPhone, two different things.
Yeah.
Well, yes and no, but it actually works differently. I'll sit in the middle so you both can see. So it's kind of a revolutionary approach to a presentation. Back to in here.
It's got a smoother transition thing.
So what a Prezi does is it's literally all one slide like this. Is as you go, like you have your slides over here, but what it does is it just zooms in to frames throughout, and it creates like this cool like motion effect. So if I go from, this is like the primary view to the first slide, it literally is just zooming all the way into that frame.
So technically,
And
it's a
then
slide,
zooming in
but
again.
Visually, it looks like it's like a more.
Yeah, it's like a slide and slide, inside a slide, inside a slide, and it just zooms in and moves. And it creates kind of a cool effect as opposed to the, just a normal PowerPoint, yeah.
Is that a Google? That's Google, right? That's Prezi, or is that?
I don't know who owns Prezi.
And the only reason I even remember this is because when I was working for another company before Met, they had this, or they referred to it. Actually, I never used it at the time, but I heard some of the other people talking about it.
Well, that was good. I mean, no one really, like, in the hotel world, no one sits down and tells you about the electrical sound and.
Yeah.
It's just like, here, get this up. Fine. And that's why I always talk about
going back to school again.
Yeah. That was the idea. I felt like,
We're all set here.
oh, yeah, we're good.
Yeah, it's just, that's why I asked to ring out the room, because I realize every room is different, because they have to reset the mixer. But this is, like you said, it's integrated, they have a limit.
Yeah, the other thing that I forgot to mention too is that in a like a space where the furniture is configurable like this one, if you do have, like let's say you ring out the room and there's a bunch of soft seating in here. Well, when you pull that soft seating out, the sound reverberates a lot more because the soft seating soaking it up. So that can actually create more feedback as well. So you have to be careful of what state the room is in when you're ringing it out, or you might be wasting your time.
Yeah, okay.
Yeah.
They've done this enough. I think Warren came in and put limits, and
Yeah.
I think he actually blocked a lot of the stuff we can get to, right?
Yeah, probably.
Yeah, a lot of stuff is locked.
We're working on that.
Is there, do you have automatic tuning? Is that available to us, or is that how they want us? to do
Tuning or mixing?
it? Mix, auto mix, like, there's a
Yes.
button they can just do.
Yes, as a matter of fact, that's one of the things that I asked Michael to talk about.
Yeah, there is a.
Because there is an auto mixing feature there, and Warren, and the only reason I knew about it was because Warren mentioned it.
Yeah.
And then, but apparently Antoine knows how to use it because I saw him using it.
I think Frank does too, Frank.
Oh, yeah, I think Frank, Buck is Frank, yeah.
Frank is, yeah. He's an old school rock and roller.
Yeah.
All you guys come from audio in this world. I think, the new Wave Guide was an audio, rock and roll guy, right? The president? He said he came to AV through music and a band.
Our old president. That was the founder of Waveguide. Yep. Yeah, he was. He jokes that we're all a bunch of failed musicians.
Yeah, that was the line of it, yeah.
Our vice president Marcus, though, was actually like legit. Like he was He had a record deal and was touring and all that kind of stuff. Yeah.
So that's
So,
But it's true. A lot of the people that come through here, you know, have backgrounds in music and mixing world, and you know,
Yep.
I mean, bring up the name from the past, Jabari. I mean, he had all those credits.
Still up
with
there,
the-
yeah.
yeah.
You might be in Mexico now with this stuff.
what he does is legal here, so
Yeah.
he doesn't need to go anywhere.
So what's your day like? You back out?
Got some meetings coming up, and then I'm going to spend the afternoon over at a law firm in Hudson Yards.
Oh.
I got to help. Today's training day, apparently. One of my one guy over there asking for more training and just general knowledge of the systems. They moved from their old building, and now he's got all this new technology, and you know, the integrator did like their thing. Let me shut it off. But they never provide that good of training. It's just this, you know, this, and that, whatever. So, so he's been asked for something a little bit more. But every time I offer to do it, I'm like, yeah, let's schedule a day. And he's like, well, I never know what the days are going to look like till it comes. And I'm like, okay, well, what do you want me to do then? So,
I mean, a law firm, they don't have to
I guess. So, finally, I'm just like, all right, I'm coming the Friday before a holiday. Like, there's going to be nothing going on, no excuses. So, we're going to do that.
Is that Freshfield, that one?
This is Clifford Chance.
Oh, yeah, that's right. Freshfield is downtown.
Yeah, three World Trade. What do I have next? 10:30. I got 25 minutes. What's that? So I haven't counted. Freshfields, Fried Frank. I'm going downtown up. MetLife, Bank of America, Pfizer, Clifford Chance. Paramount's going away, so that would have been 7. But yeah, I guess it's 6 now. Yeah.
Oh, wow. Paramount's just like a street, it's like a streaming space, right?
It's a members-only club.
Oh, that's
Yeah, and really wasn't anything that they. Well, they were not. I don't think that they're doing the right thing. Quite frankly, I think their strategy is wrong. But they think they're going to save money by getting rid of us, and they're not, because their expectation of this internal person they're hiring is much more than what we ever were doing.